Hi, this is lesson 9.1, and we're going to be learning about sequences. Now, first of all, a sequence is an ordered list of numbers. And the terms, those are what the values are called in the sequence. So in this sequence of numbers, this is a list, we have 2, 4, 6, 8, 10. This 2 is the first term. The 4 is the second term. Now, we use the way that we denote them, the first term we call a sub 1. 1 means the first term. A sub 2, 2 means the second. A sub 3, 3 means the third, and so on. And eventually, when we get to the nth term, we would call it a sub n, which means the nth term. Now, if you look at these numbers, so the first term is 2. The second term is 4. I'm going to write this another way. So the first term, n, is 2. The second term, when n, a sub 2, so n is 2, that is a 4. The third term, a sub 3, is 6. The fourth term, a sub 4, is 8. So look at what's happening to the n. N is getting multiplied by 2. So on the fourth term, the answer is 8. So on the fifth term, the answer will be 10. So like let's say we have the 100th term, the 100th term, it would be 200. You're multiplying by 2. So the rule we would say is a sub n is equal to 2n. This is called an explicit formula. An explicit formula relates each term to its position in the list. It looks at the n value. So when n is 3, the term is 6. And when you're trying to come up with a rule, you want to ask, what is happening to the n? So first of all, it says write the first 6 terms of the sequence. So we're just going to practice. When we're given an explicit rule, we're going to write the terms. So let's write a sub n, and n, we'll make a little chart here. So when n is 1, a sub 1, so in other words, we're going to substitute in a 1 for n. You get 5. So the first term is 5. A sub 2, so we substitute a 2 in for n. That gives you 6. And when we substitute in a 3, a sub 3, we have 3 plus 4, that gives you 7. A sub 4, when you substitute in a 4 for n, 4 plus 4 equals 8. Now hopefully you see that we have 5, 6, 7, 8. So the fifth term will be 9, and the sixth term will be 10. We can see the pattern after we do a few, and then we're able to just finish and finish writing the 6 terms. Here's another one. It says f of n equals -2, and that quantity is raised to the n minus 1 power. And you can also think of this as a sub n. So this f of n is written in function form, but when we want to make the sequence of numbers, we may want to write a sub n. So n, let's make our little chart, a sub n. So when n is 1, we want to know, what does a sub 1 equal? Well, a sub 1 would be -2 to the 1 minus 1. 1 minus 1 is 0. -2 to the 0 power is 1. So now we'll do a sub 2. So when n is a 2, that means we're going to substitute in a 2 for the n. So 2 minus 1, that's a 1. So -2 to the 1 power is -2. A sub 3, we have -2 to the 3 minus 1. 3 minus 1 is 2. So -2, quantity squared, is a positive 4. Now notice what's happening. We have a positive, a negative, a positive. A sub 4, we have a -2, and we're going to find what the fourth term is. So that's 4 minus 1, which is 3. So you have -2 to the third. It's a -8. So can you see the pattern? we are doubling every time, and the sign is changing. So if we double 8, we have 16, and that's going to be a positive. And then when we double 16, we get 32, and that's going to be a negative. So the sixth term would be negative 32. So there you have your 6 terms. All right, the next example, we have a sub n equals n over n plus 1. So we'll just write it in a column here. A sub 1 then would be 1 over 1 plus 1, which is 2. A sub 2 would be 2 over 2 plus 1, which is 3. A sub 3 would be 3 over 3 plus 1, which is 4. So notice this number is the same as this. This number is one more. So that's our pattern. A sub 4 then would be 4 over 5. A sub 5 would be 5 over 6. A sub 6 would be 6 over 7. There are your first 6 terms. Now the next slide says describe the pattern, write the next term, and write a rule for the nth term of the sequence. So this first one is -1, -8, -27, -64. Now, when we want to write a rule for the nth term, we are going to be writing an explicit formula, which means it's in terms of n. So I always like to make a little chart here when I do this. I think it makes it easier. So the first term is -1. The second term is -8. The third term is -27. The fourth term is -64. All right, and then we're going to have to find the fifth term too. So the rule is a sub n would equal, and so what we want to do is look at your n values in relation to the a sub n. So can you see a pattern of what's happening? Hopefully you can see that n is getting cubed, because 2 cubed is 8, but also there's a negative in front, so you're taking it times a -1. 3 cubed is 27 times a -1. 4 cubed is 64 times a -1. So to get the next number, we take 5 cubed, that's 125 times a -1. So there we have the rule right here. All right, for the next one, again, let's put it on a little table. So first term is 0. Second term is 2. Third term is 6. Fourth term is 12. And then the fifth term, we'll have to find that. So the rule to find a sub n. So we want to look at n, each number, and then the n above it. So if you look at 2, you have a 2 above it. If you look at 6, you have a 3 above it. If you look at 12, you have a 4 above it. So we're looking for patterns here. We need to end up with a 12. And if we're looking at the number above it, 4, let's see, 4 times 3 is 12. So 4, that would be the n. The number in front of it is 1 less, so that would be n minus 1. Now let's see if that works. So let's look at this one. So to get 6, if we look at the number above it, the position is it's the third number, and you take it times 3 minus 1, which is 2. 3 times 2 is 6, so this times this is this one. And again, 2 times 1 is 2. 1 times 0 would be 0. So to get this number, we're going to look at the number above it, take it times the number before it. So 5 times 4 would be 20. Another way to think of that would be n squared minus n. It's equal to that if you distribute. Now if you look at 3 squared, that's 9. 9 minus 3 is 6. 4 squared is 16. 16 minus 4 is 12. 2 squared is 4. 4 minus 2 is 2. So you can think of it that way too. Let's do another one. Again, we want to make a little table here, and when the numbers are there, we'll just put the n's above. So we have the first term, second term, third term, fourth term, fifth term. So we want to look at a sub n. So this is the a sub n here. This is the n up here. What is happening to the n to give us this number? Well, 2 to 5, 3 to 10, 4 to 17. Well, let's see here. Let's think about the squares of the number. If you squared this, you'd have 4, and then this is 1 more. If you squared this, you'd have 9, and this is 1 more. If you squared 4, you'd have 16, and this is one more. So it looks like the pattern is n squared plus 1. So here, 5 squared is 25, plus 1 more would be 26. And then let's look at the next one. So first term, second term, third term, fourth term, fifth term. And these are the n's, and this is a sub n. So let's see what's happening. We look from here to here. Can you see the pattern? Your n's, so a sub n, your n's are getting multiplied by -4. So that's your rule. So your sixth term would be -24. So now the next type of pattern we're going to be looking at, and the rule would be using a recursive formula. So to use a recursive formula, what we do is we determine a number based on the number that comes before it. So if we look at this pattern, 133, 130, 127, we'll say, what is happening to each number? So to go from here to here, you're subtracting 3. To go from here to here, you're subtracting 3. So we're going to write the rule for this, but we're going to be looking at the number ahead. And here's how we do that. First of all, this is your first term in this pattern. This is a sub 2, the second term. This is a sub 3, and this would be a sub 4. Now let's generalize that. This would be a sub n. So if this is the number we're looking at, the number in front of it would be a sub n minus 1, because this is like a sub 4. 4 minus 1 gives you 3. So if this is a sub n, the one in front is a sub n minus 1. The one in front of that is a sub n minus 2, because 4 minus 2 is 2. The one in front of that would be n minus 3, a sub n minus 3. So a recursive formula is a way to describe a term in terms of the number that comes right in front of it, and then what do you do to that number in front of it to bring you to your term. Now the thing is, because we're always looking at the number in front, you have to have a starting place, and so you always have to define what the beginning number is in your sequence. So a recursive formula has an initial condition. That's your a sub 1. It relates each term after the first term to the one before it. And when you are coming up with the recursive formula, you ask yourself, what is happening to the term in front? So here's an example. It says the number of blocks in a two-dimensional pyramid is a sequence that follows a recursive formula. What is a recursive definition for the sequence? So let's put numbers to these pictures. So in the first number, or the first term, n equals 1, first term, we have 1 block. In the second term, so n equals 2, we have 3 blocks. In the third, we have 6 blocks. In the fourth term, we have 10 blocks. In the fifth, we have 15. So that'll give us a good idea here. So to write the recursive rule, we first want to say what is the starting. So a sub 1, your starting term, a sub 1, so a sub 1 is 1. So a sub n, so let's just pick a term, a sub n. So we want to look at the term before it. So I'm going to write on the other side a sub n minus 1. So a sub n is a term. A sub n minus 1 means the term in front of it. So what are we doing to the term in front of it to get this one? So to go from 3 to 6, we're adding 3. To go from 6 to 10, we're adding 4. To go from 10 to 15, we're adding 5. So let's look back here. The term in front of the 6 is a 3, and we're adding this number. The term in front of the 10 is a 6, and we're adding that number. So to get this term, we're adding n. To get this term, we're taking the number in front and adding n. So you're adding n, the number above it. So this is your rule. So like to get to find a sub 6, the 6th term, you would take the number in front, which is 6 minus 1, so that would be a sub 5, plus n. N is a 6. What does a sub 5 equal? It equals 15 plus 6, you get 21. And sure enough, if you count your numbers over here on your sixth pyramid, you would have 21. Let's do another one. What is the recursive definition for each sequence? So let's put the term numbers, the values above here. So this is your first term, second term, third term, fourth term, fifth term. This is your sixth term. So this is n. So recursive, we want a sub 1. What is the first term? It's 1. Now for any term, we're going to be looking at the number in front of it, so I'll put that over here. So if we look right here, 6, the number in front of it is 2. Okay, this number is 24, the number in front of it is 6. This number is 120, the number in front of it is 24. Do you see a pattern? Well, going back here, the number in front of 6 is 2, and if you take it times 3, you'd get 6. Okay, look at 24, the number in front of 6. If you take it times 4, it's 24. So it looks like what we're doing is we're taking the number in front and multiplying by n. So like for this term 120, you take the number in front, it's 24, multiply that by 5, you get 120. So there's your rule. Here's another one. So first, second, third, fourth, fifth term. So a sub n, and over here we'll write a sub n minus 1, because to find this term, we're going to look at the number in front. And as I look at it, I see we're not multiplying by anything. And so when I'm not seeing that, I might look and see what is the difference between the terms, just to see if I can find any pattern. There's 4 between there, 9 between those, 16 between those terms, and 25. Well, hopefully you recognize that 4 and 9 and 16 and 25 are all perfect squares. And as a matter of fact, to get 5, what did I do? I took the term in front and I squared the 2 and added that. To get 14, I took the term in front and then I squared the 3 and I added those together. 9 plus 5 is 14. To get this term, okay, I took the number in front, which is 14, squared the 4, 16 plus 14 is 30. So what we want to do is add to the term in front of it n squared. There's your rule. And again, we have to say, what is the starting point? It's 1. So let's look at another example. We'll just look at that rule a little bit. So like, let's say we want to find the sixth, a sub 6, the sixth term. We would look at a sub 6 minus 1 is 5, whatever that value is, plus n is 6, 6 squared. So that would be a sub 5 is 55 plus 36. That gives us 91. That would be the next term, the sixth term. All right. So this is the assignment, and here I have some examples from each group. Number 8, it says, this is the rule, it's the explicit rule, you're supposed to find the first 6 terms. So the first term, n is equal to 1. So negative 5 times 1 plus 1, that's negative 5 plus 1 is negative 4. A sub 2 would be negative 5 times 2 plus 1, that's negative 10 plus 1 is negative 9. A sub 3, so you're substituting in a 3 for the n, negative 15 plus 1 is a negative 14. A sub 4, so that'd be negative 20 plus 1 is a negative 19. So hopefully you see, oh, we are subtracting 5. So the next term would be a negative 24, and after that you subtract 5, negative 29. So these are the first 6 terms. In number 20, we are asked to look at this list of numbers and write the recursive rule. Remember, recursive means that you look at a term and you want to describe it in terms of the the number in front of it, the term in front of it. So like if you look at this is your first term, a sub 1 equals 1/2. What are you doing to go from here to here? From here to here, from here to here? Well, the numbers in the denominator are doubling. The numbers in the numerator are staying the same. So you're taking every term times 1/2, times 1/2, times 1/2. So it's 1/2 times the term in front. That's how you get your next term. Number 29 in that group, they're giving you the list of numbers too, 5, 10, 17, and that is an explicit rule, which means you're going to use an n in the way that you describe the rule. So if you look at 2, how do you get to 5? If you look at 3, how do you get to 10? If you look at 4, how do you get to 17? And we talked about that earlier in the lesson. That one, you square the n and add 1. Square this, add 1. Square this, add 1. And that is it for this lesson. Let me know if you have questions. Thanks.